1 plus 2 equals 3. Now we're going to, while I'm showing you how we're working with 1 plus 2 equals 3, we're going to do A plus B equals C. But I'm not saying that A, B, and C, anytime you see A, B, and C, that it's always equal to 1, 2, and 3. That's not the case. I could use X plus Y equals Z. Okay? The letters we use does not matter. What matters is the position. So we're going to observe the numbers in their positions, or the terms in their positions. Okay, meaning we have something that we write that's a term. We're going to add another term, and then that's going to equal something. It's going to give us our result. This is what I mean by the positions. Okay, here 1 plus 2, 1 plus 2 equals 3. Okay, we have A plus B, C. Okay. Observing, we are observing the terms and their positions. Okay, so now first, okay, we're going to see what happens when we subtract 2 from both sides. 1 plus 2 minus 2 equals 3 minus 2. If you look at what we're doing with the different positions, so B, here on the right, B is in the same position too as this, so we're going to say over here we're going to subtract B from both sides. Okay? A equals C minus B. Here, now we don't want to complete the calculation, but just get the same numbers, different sides of the equation. Okay. Now here we see this is equivalent. The forms are equivalent. So here's what we're given. Up top, this is what we're given. We're given to work with. And then from what we're given, we rearrange each formula to find out how each term relates to each other within that relationship. Here we have 1 plus 2 equals 3. On the left side of the equation, 2 is positive, so we move it to the right side of the equation, it becomes negative. See? Likewise over here, A plus B equals C. On the left side of the equation, B is positive. If we want to move it to the right side of the equation, then it's going to become negative. So it's going to become its opposite sign because we're moving it to the opposite side of the equation. We're moving it by addition. Alright, now we subtract 1 from both sides. So we get 1 plus 2 minus 1 equals 3 minus 1. And here, A is in the position 1 is, so we want to subtract A from both sides. And then that breaks down, that becomes 2 equals 3 minus 1. Here you get B equals C minus A. The basic formula rearrangement. So it's showing you letters. If I start off, if I say A plus B equals C, see, algebra shows you what to do with numbers if they were in their position. Here, you can just remove, I can remove C even. Let's say if we subtract C from both sides of the equation. Okay? So, A plus B minus C equals, well, anytime let's say we write this out, C minus C. A plus B minus C equals 0. Okay? Now if you have 1 plus 2 equals 3. Now subtract 3 from both sides. 1 plus 2 minus 3 equals 3 minus 3 equals 1 plus 2 minus 3, that equals 0. You see, I didn't even calculate this yet. But we can find out, we know 1 plus 2 is 3, then 3 minus 3 is 0. So that's true. So that means that when I did the arrangement for the letters, that was true. Now if we go back to up here, if I bring B to the other side of the equation, you're going to get, or if you subtract B from both sides, you get B minus B equals C minus A minus B, which is 0 equals C minus A minus B. So here you're finding out how to set equations equal to 0. You see why this is so. I can subtract 2 from both sides over here. Two minus 2 equals 3 minus 1 minus 2. Okay, here you get 0 equals 3. I'm not going to put them in order. 3 minus 2 minus 1. Okay?